In this lesson, we're going to look at patterns in the multiplication table. Did you know that the product of two counting numbers is a multiple of each of those numbers? Remember, a product is an answer to a multiplication problem. To find the multiples of 4, we multiply by the counting numbers 1, 2, 3, and so on. So to find the multiples of 4, we can do 4 times 1, and that gives us 4. So 4 is a multiple of 4. Then we could do 4 times 2, and that gives us 8. So 8 is a multiple of 4. We can also do 4 times 3, and that gives us 12. 12 is a multiple of 4. Do you know what the next multiple would be? You're right, it's 16. Now let's look at the row or the column for the factor of 4. Now, if you look at a multiplication chart, you can see factors written across the top and factors written down the side. This is a column that shows the multiples of 4. This is a row that shows the multiples of 4. It tells us to circle those multiples of 4. What patterns do you think there might be? Well, I think the pattern is that it's going to list all the multiples of 4 in order. So, all the multiples of 4 will be in order across the row or down the column. I can check this by circling all the multiples either across the row or down the column and see if those are all the multiples of 4. So let's try that. Well, I know I have 0, and then 4 times 1 is 4. 4 times 2, well, that's 4 more, so yeah, that's 8. 4 times 3, that's 4 more, so that's 12. 4 times 4, 16. Yeah, it looks like all my multiples, all the numbers in the row are all the multiples of 4 in order. You know what other pattern I noticed? I noticed that every multiple is adding 4 each time. 4 plus 4 is 8, and 8 plus 4 is 12. That works here, but let's start on 24 and see if that works. 24 plus 4, 25, 26, 27, 28. Yeah, that's right. 28 plus 4 is 32. 32 plus 4, it is 36. And 36 plus 4, 36, 37, 38, 39, 40. 40, there we go, we got it. So that is another pattern that you can see in the multiplication table. You know what, I just noticed another one. 4 is an even number. And every one of the multiples of 4 is also an even number. Do you see any odd numbers in that row? I don't. They all end with E. All these numbers have an even number in the ones place, so they're all even numbers. That's interesting. I wonder if that works for other even numbers. 2 is another even number. Let's look at all the multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yep, all those are even. Let's try another even number. What's another even number between 0 and 10? Yep, 6 is one. So let's look down our 6 column and see if we see all even numbers. Looks like they're all even to me. Pretty neat. Now, this next section says shade the columns for multiples of 1, 3, 5, 7, and 9. What patterns do you see? Well, I'm not going to shade them because I don't want to block the numbers, but I'm going to kind of circle them. Oops. It's kind of tough doing this here on the computer. So there's 1. Let's look at 3. Look at that. It's a little better. 5. 7, and 9. Now, what do you know about 1, 3, 5, 7, and 9? Are they even numbers? No. 1, 3, 5, 7, and 9 are all odd numbers. Let's see if all of those multiples are even numbers. 1, 2, 3, 4. No, they're not all even. Are they all odd? 1's odd, but 2's even. And 3's odd, but 4's even. And 5's odd, but 6 is even. I'm noticing a pattern. The multiples are odd, then even, and odd, and even. So all the odd multiples are odd, and if we multiply that number by an even number, it's even. Let's see if that works for 3. Odd, even, odd, even, odd, even. Wow, it works for 1, it works for 3. Let's try 5. Odd, even, odd, even. Wow, I bet it's going to work for 7 and 9. Let's try it. Odd, even, odd, even, odd, even. Wow. Here we go. Odd, even, odd, even, odd, even. Pretty neat. So, the multiples go in a pattern. Odd, even, odd, even. Pretty neat. Now it's your turn to use the patterns that you see in the multiplication table to do some practice problems.